You can ask me to make up kinds of questions. Why am I putting it way the shit over there? So today is pretty much driven by what you guys want to focus on. Yes?
Can you do 2D on the test?
Let's find out. 2D. Ooh! Sorry, I'll calm down. Oh, let me say this. There's a decent chunk of you here now. And I'm recording this, so maybe somebody else will hear it. I want to say something in general about, go back. I want to say something in general about math, okay, especially calculus. Do you all agree with me that derivatives, if you know the rules, you just attack? You know, in fact, does anyone understand you should feel very good about derivatives? You know you can just attack them. Integrals are a completely different thing, yes? We know they're the opposite of derivatives, and that is why they are so much harder. Because if there isn't a clean place something came from, then I've got to kind of invent all these methods to figure out where it came from. What I'm trying to say is this, and people don't seem to believe me when I say this. I've assigned a decent little chunk of homework. Some problems are really clean, some problems you can get after a little bit of thinking, and some problems feel impossible. Does anyone agree with that? The big thing I'm looking for is that you know what to try. You know what you're allowed. You know what you can try. You see what I mean? So this is very different from like algebra. This is even different from Calc 1, where if you just know the rule, you can do it. If you know the rule, you can do it. Integration, you're starting to understand there are processes. There are things you can try. There's no hard and fast rule for some integrals. I don't know if you're really going to hear what I'm trying to say, but when you're doing a problem, I'm grading primarily on, do you even know how the process you're trying to use works, and do you know how to tell when you want to try certain things? Getting the answer, now if you get the wrong answer, you're going to lose a few points, but nowhere near as much as if you didn't know what even to try. Are you guys understanding? So when you're doing your homework, if you hit a problem that is like, I have no idea, and you get some help from people, and they're not really sure, let it go. Get what you can from that problem. The answer is not the point, which sounds weird. I know. In real life, the answer is the point. You want to build the damn bridge. You got to know the answer. We ain't building bridges here that I'm aware of. We're getting used to processes. I don't know if you really. All right. So when you're doing the homework, don't allow like 3 problems to ruin your day. If you're able to do like more than half of the homework set, it's really good. If you're able to determine what to try to do in a problem, that's really good. If you have a few problems you just cannot get, do what you can. Try something. Yes? Okay, I'll stop. Now, did somebody have a question that I totally ignored, or what happened? Did I just go off on a tangent? Anybody have 2D? 2D, okay. This is a really beautiful example of this. If I gave this to you on a test, right? You do not want to waste a ton of time on this if you can't see what to even try. But you don't want to leave it blank. You want to try a few things. So this is not a clean integration problem, correct? I don't see something in there that's the derivative of something else. I did this problem a specific way on the practice test answer key, because I think it's the way that might jive with most people. But there's so many more ways to do this. Did anyone try 2D out and think they got somewhere? All right, let me see you guys. Okay, what'd you do?
I made the denominator u.
Okay, so you made u the denominator, which in general is kick-ass, because if the bottom is more than one term, that sucks. So one thing u sub does for us is it allows us to make the bottom into one term, and we're just hoping everything else works out. What did you do the similar thing? Or?
I tried doing that, but then it didn't help, and then I tried doing only x, but that's just changing variables.
Sure.
The one that worked was making the square, the cube square thing.
The cube root?
Cube root square x.
Cube root, yes.
And then divide.
Okay, so you made u equal to cube root.
Yeah.
Okay, interesting. And you did the same thing?
I did the same, but then I had to do the long division thing.
Yes, okay. And if you just make the bottom u, I'm pretty sure it just kind of, you can mess with it and get into a polynomial in u. Yeah. Okay. So this kind of problem, in general, don't just erase everything. Unless you figure out the right way and you're like, okay, don't look at this, look at the right way. If you don't get to the answer, leave me your attempts. I'm going to grade you on, did you determine what might work, and then how far did you get? Did you get hit on the snag? Did you apply the process correctly? You guys kind of with me? I would never give a Scantron test because the answer doesn't matter as much. It just doesn't. That's my general philosophy, not just in Calc 2, but here it really doesn't matter as much. It matters, don't get me wrong, you gotta lose points if you don't get the right answer, but not as many points if you didn't even know what to try to do. Okay, maybe. Let's do this. Did anyone not even try 2D at all? Can you be honest, did you not even try 2D? Anybody? A few of you guys? Does anyone not want to admit if they tried it or not? Okay, all right. So everybody else tried it. Did anyone try something different than what these guys said? Yes. Oh,
Oh yeah, that's right.
so real quick, conjugate, all right, because this is a cube root, things get so much worse. If it's a square root, that goes with squares, difference in sum of squares, so I only need two kind of things for that. If it's a cube root, there's no conjugate that will clean this up, because if I multiply by cube root of x plus 1, then I'm still going to have a cube root of x squared. It doesn't make the radical go away. But that could still go somewhere. All right, look. One thing to notice on this problem. Let me start this off with, if I just let u equal the cube root of x, what is du? Jeff, you can do it. Is everybody cool with that?
Yeah.
Obviously, I don't have that directly in here, do I? But if I multiply by this, I do have this kind of show up. So there might be an avenue to go with that, but it feels like not quite. But I mean, this is a very good just first level, just let me show myself what I would need if I wanted this to be a direct u sub. I would need that. I don't see that. I don't see it. So you can't just do it. But you could, all right, just to kind of talk about some ideas. I'm not saying any of these are right. I'm not even working them out of my head. If I multiply top and bottom by this, then it does show up. And then I can maybe hope that the bottom becomes something nice, but probably not. I mean, I understand if you're like hoping, I could just tell you, oh, when you see this, do exactly this. When you see this, do exactly that. Ain't what's happening. You have methods to try, and you want to try them. So what I said, rule out u sub. So I love all of this. All of you had told me it's basically a u sub, and I agree, it is. It's a creative u sub. Okay, maybe. So if I wanted to be a direct kind of u sub, I would need this to be in there. This is not in there. So let's try something else. And I've shown you a problem like this before, but if you let u equal this, what's x? I'm sorry, let's make it the bottom. Okay, let me turn this around. If I let u equal this, so u is x to the 1/3 minus 1. What is x? Add 1, and then cube both sides. Is that cool?
Yes.
Now, there are some generalizations I can make. When I pick u equal to some function of x, I for the most part, I could solve for x, unless I have a non-invertible function in there. Cube root's invertible, so I can solve for x. If I can do that, I could try to attack this from the other side. So normally I let u equal something, and then I figure out what du is, and I have to have that in there to be able to do it. And I didn't. If I solve for x, it's a little cleaner. What would dx be?
3 u plus 1 squared.
And the inside's linear, so
Nothing.
chain rule doesn't give me anything.
Yeah.
Linear slope 1, I should say. Yeah. Let me stop for a minute. Do you guys, you have to absorb that this kind of u sub is a potential thing that would work. Where I let u equal something, but then I solve for x. And what kicks ass about this kind of substitution is I know exactly what dx is. I don't have to like make something show up. I just replace dx with it. Yes.
So can't we do the same thing if u was just x?
Yes, totally. I'm not saying what you said was wrong. I'm really sorry. I do want to remind you that if I were doing this, in general, I would suggest that if the bottom is more than one term, I'll let u equal the whole thing. Because the bottom being one term is generally also. Off the top of my head, I can't reason out at the moment what yours is going to lead to. It should work, I'm pretty sure. Okay. So then, here's what this becomes. If u is the cube root of x minus 1, what's the cube root of x plus 1? Or even different, what's the cube root of x? U plus 1, yes? So what's the cube root of x plus 1?
U plus 2.
And the bottom is what u is, yes? And what's dx?
3 u plus 1 squared.
Yeah, 3 u plus 1 squared. Is everything in terms of u now? Is the bottom one term? Does that mean I'm able to multiply the top out and then divide each piece by the bottom? I mean, do you see how that worked? So, listen. If you're uncertain what to try letting u equal the entire bottom. I'm not saying it's going to work. But I am saying if it does work, the bottom is one term. And the bottom being one term kicks so much ass because then I'm allowed to break it up. That might not work though. So obviously on the test, I can't give you every problem as something where you're like, this might work, no, this might work, because that'll take forever. I am going to make some that are clear cut. And I will tell you this about the test. I will have a little section that will tell you which method to use, just so I can see you know how to do the method. And then I'll have another section that's just wide open. You got to figure out. Does that make sense? All right. Because sometimes I make a problem and I want you to do it a certain way, but another way would work that I didn't even think about, and then I never test you. Do you know how to do this specific thing? Okay. All right. Is everybody cool with this? Is this the only way to do this problem? No. I'm pretty sure the other way worked. Try it. But now the 3 can come out. I can foil this into all that business. I can divide every piece by u. It's just a polynomial now. Not polynomial, but it's just power rules. Maybe. I don't know if you guys, so a huge part of calc, even starting in pre-calculus, trig identity proofs. Was there one clear-cut way to do those? No. You tried something, it didn't work. You're like, okay, that's data. Let me try something else. Now I'm eliminating possible ways to go. Same kind of thing here. Sorry, does somebody have a question? Yes?
Can you explain again how you got u plus 2?
Oh, yeah. Okay. 2 ways to look at this. Cube root x minus 1 is u. So cube root x plus 1 has to be u plus 2. Or, do you agree cube root of x is u plus 1? Cube root of x is u plus 1, yes? So then what's cube root of x plus 1? U plus 1 plus 1, u plus 2. So don't forget, you're not going to have to do this all the time. In fact, you don't, because you never did this shit in Calc 1, for example, and you learned u sub in Calc 1. But if you let u equal a function of x, very often you can solve for x. The best thing about trig sub, and I know I don't really blame you. It makes me sad because I love trig sub. Some of us don't like trig sub. But if you think about it, the best thing about trig sub is you're doing this shit. X equals function of theta, dx equals this shit. No thought, replace dx with that shit. No thought. You just straight up replace it. That's what this becomes. X equals shit, dx equals, okay, just plug this shit in, just replace dx, that's beautiful. Normal u sub, I gotta make this show up, and I gotta do this over here. It's a little more amorphous. This is just straight up, just plug the damn thing in. Okay, and this is an option to try. I know you want me to tell you, oh yeah, when you see this, this will always work. I can't. I'm not being mean, I just can't. Okay, you're learning more things to try. But like I said, every problem on the test is not gonna be, let's see if you picked the right way. I'm gonna make some that are very straightforward, so I can see that you understand the idea. I have to make a few that are, give something a try. Okay. That wasn't really necessarily make you feel better, but it's just to let you know how things are. Yes?
I have a question on the homework problems.
Sure. Where are we at?
7.425.
Oh, I'm always doing that. 25. Ooh, yeah. So what's the immediate thing about 25 that should jump out at you?
The top
Longer
is-
line.
Yeah.
Yeah, because the top power is
Right.
greater than the bottom. The great thing about that is I'm gonna get like a whole part and then a fractional part, right? Just like a top-heavy fraction with numbers. This is a top-heavy fraction with polynomials. I'm gonna long divide. Now, some of you guys notice you can synthetically divide, I'm sorry, you can factor the bottom. Do you guys see that? I almost want to show you this and I really almost don't. I think somebody synthetically divided for this problem by 1 and 2, because this will be x minus 1, x minus 2. Are you with me? You have got to be really careful about what the remainder term does. The remainder term at the end is going to be divided by both x minus 1 and x minus 2. Okay. It would be believe it or not, it'd be better to do long division, because synthetic you got to do it twice. So long division would just be one thing and you're done. Synthetic, you'd have to be careful about remainders. Okay. You guys semi with me. I need you to see, you can factor the bottom, correct? Yes, of course you can, because eventually they want you to do partial fractions. But if you're going to do synthetic, you've got to be careful, because the remainder is there, and it's a little trippy what to do when there's a remainder and you want to divide again. That's trippy. So I'd highly recommend you just do long division. Is that where you got stuck, or did you do that?
I did long division and I got stuck after that.
What'd you get for the long division? Okay. Oh, okay. So
Yeah.
let's see. I think something went freaky, because show it to me again. Show it to
Yeah,
me
I
again.
think maybe I did it wrong.
Yeah, okay. I see what you did. Okay. So just very quickly, where'd it go? Here it is. Okay. Here, you guys, I'm gonna do you a favor, and you're gonna help me out a little bit. How do I have to be careful about what I'm writing right now? Right at this moment, I have to be careful.
You have to
Plus
0 x
0
squared.
x
all the
squared
Good. I have no x squares. Where'd it go?
minus
Nice.
4x.
Okay. So here's the problem written in a long division form. Everybody's favorite.
Yeah.
None of us twinge when we say yes. We do. We all. Okay. X squared times x is x cubed. I'm going to do this a little bit quickly. X times x squared is x cubed. Don't look up there, Jeff. X times negative 3x is negative 3x squared. X times 2 is 2x. And then I change the signs. These cancel. 3x squared minus 6x. Bring down the plus 1. Plus 3x squared times 3 is 3x squared. So 3 times x squared that's insane. 3 times negative 3x is negative. I'm doing this a little quickly. But it's just a bunch of multiplying and subtracting. Who gives a shit? 6x is be 3x, and this will be minus 5. Is that what you got? Now here's where your mistake was. That is a whole part, yes? It's like a mixed number. So this will be x plus 3 by itself. Then plus this over this. You had this over this, and it was looking way worse.
What? Nope.
You had this over this.
Oh,
See that?
So your answer is just the top of that. You
okay.
have to divide it again.
Does that make sense?
Divide it.
Yes. So you have this integral, and then you have this integral. And this one you can do partial fractions.
So you put
Okay.
the remainder over the thing
Do it again.
here.
Do it again.
You put the remainder over the thing over here, the x squared.
You ready? You ready? Is everybody ready? Is everybody ready? Do 7 into 17. Do it. Do it.
Add 2,
2.
and then you have 3 left. Plus.
Yeah, we know there's a plus here. It's the worst decision in all of math history to write these next to each other. But
Correct.
I mean, so why does this work the same way? Because these are numbers and so are these.
Mm,
This is a number I don't know yet. So should it work the same way as shit? Yes, it should work exactly the same way, and it does. I did every step exactly the same.
I forgot we used to write numbers like that. We just put it next to it, right? And
Yeah.
now we multiply
This
any
was the
number
dumbest-
that's next to it.
Well, this was one of the dumbest decisions in all of math history. Because then students think this is 6/7, because if it's sitting next to it, you multiply, but there's a hidden plus sign. Yes. But of course, with polynomials, the plus sign has got to be there.
What would it look like with synthetic division? You would have to like FOIL it out, right? This just looks.
So
ugly.
just very quickly, this is clean. This is clean, and I'm done. And you're like, what's your definition of clean, Jeff? There's not a lot going on. I did the same thing 3 times, and then I was done. Just because you asked.
Because the bottom would be x minus 2 and x minus 1.
Here's the problem. So, just real quick, I don't want to spend a ton of time on this, but just to show you, because it is interesting. If I synthetically divide by 2, yes, I get 1, 2, 2, 4, 0, 0, 1. That right there, what is this right there? X squared, I'm sorry, this whole thing, I'm sorry.
Plus 2x 1 over.
Because there's no constant term, yes?
Yeah.
Okay. That right there is this thing. If I synthetically divide by 1 now, is that right? Yes. Watch. 1, 1, 3, 3, 3, 3, 4. I think that's right. Okay. So now this will be x plus 3x plus 3 plus 4 over x minus 2, x minus 1. There we go. I might have, wait, Jeff.
Why only 1?
Sorry, this will be over x minus 1. There we go. I was off by 1. So this will be x, because I divided twice. So I have 1x left. This is the constant. This is over x minus 1, because it's the remainder for this. This was already over x minus 2, so now this is over x minus 2 and x minus 1. That's trippy as shit. Yes?
Yeah.
What's cool about this, though, is this is the answer to your... Well, this is not the answer. This is written in a way that you can integrate this piece. You still have to do partial fractions for this, though.
Yeah.
But you see how the partial fractions for this, by itself, will be a little easier than the partial fractions for this. Okay, maybe. But again, dear God, do you see how this is really weird and you have to remember the remainders and how they each work? This is a remainder from this division. This is a remainder from this division and this division. So it gets both parts on the bottom. Really easy to forget that. So I highly recommend you don't do this unless it makes complete sense. You guys kind of with me? I'm kind of happy I showed you this, but please, dear God, it's up to you. Okay. If it doesn't make sense, just don't do it. Yes.
Can you do I on the practice test, please?
Oh, yeah. This originally was going to be a, what do you call it? Improper interval. And then I decided to change it a little bit. So the answer is going to be a little bit weird, but oh well. So I was going to start at 9. So then this would be, right? And then I thought, no, I'll just have 2 of those. What method do we use?
Use some.
Okay, let's talk about this. Several things. And you want to slow yourself down. By the way, do you guys know what a memory dump is?
Yes.
Memory what?
Memory dump. So when you get a text, you immediately write someone back in the corner, all the things you're supposed to remember. You with me? I had a teacher that tried to outlaw that. You're not allowed to do that. Screw you, man. I'm gonna do it. I'm gonna erase it, write other shit, and erase that, and you won't know. So screw you. I don't give a shit. It makes sense. So there's some of you like, I never remember the cosine squared. Immediately write it on your test. I don't give a shit. You guys gonna. So if I were you, I would put step 1, simplify. Step 2, rule out u sub. Step 3, oh shit, something whatever. You with me? So would u sub work here?
Yes.
Hell yeah! So would I want to do trig sub if u sub works?
No.
Just about never. Would trig sub work? Yeah, of course it would. Totally. But do I have to do it?
No.
I'm not gonna do that shit. You guys kind of with me? I'm not saying you're wrong if you do it. I'm just saying you're doing more work than you have to. You with me? Okay. So that's why I tell you, rule out u sub before you do something else. Because if u sub works, it almost always will be the easiest way to do things. Okay, is that all right? Is that part of the reason? Do you get stuck with the trig sub stuff? I'm not even sure what this will look like for trig sub, to be honest.
When you change the limits of integration is super ugly, so.
Yes, so I didn't even have an eye towards that because I wasn't even thinking that way. So I'm not gonna put any ownership over what it looks like if you try to do
So
trig
you're
sub.
saying if it starts looking very weird, we should try a different method?
Yes. Yes. Yeah, I mean, in general, if you start to lose touch with it, or with the parts you start getting, it just gets even worse, then just stop and start over. Just go, is it a U sub? And if it's not a U sub, then you're like, well, it's just Jeff being an asshole. I'm gonna try to do as much as I can. Okay, I'm gonna try not to be an asshole, but you know, I'm a math teacher, so it's somewhat in my nature. I really hope somebody else doesn't believe that, but maybe. Is that all right for this one? But do you see what I mean? It's really good to write that up at the top. Rule out U sub. Even if you just want to write rule out U sub for yourself, so you don't forget. Also, just to let you know, there's going to be at least one integral where if you just simplify first, it'll be easier. Yes? So that's another big thing my Calc 1 students can tell you. I was always saying, simplify the function before you attack it with calculus. Yes? What could simplification mean? Factoring and reducing. It could mean trig identities. It probably means trig identity. We'll see. Okay. If you do that, then it becomes easier. Yes? And you've seen that from me before. Okay. All right. Anything else about 2i there? All right. Who's got the next question? Yes.
This is like a bit of a more general question that I came across in the homework. I was on WebAssign, it had like a problem where it was like, oh, do this integral, but do it like 4 different ways and stuff like
Oh,
that.
yeah. It's in the textbook too.
Yeah, and it gives you like a different answer for each one, and I'm curious how that works, because does that mean like
Is that the one where the one answer is 2 sine squared?
Yeah, and like one's like something cosine.
Because through identities, you can make one look like another one.
Okay, so they're all like technically the same answer, just written different.
Yeah, so watch this, watch. If one answer was 2 cosine squared theta plus c, and another answer was, you can do it, Jeff. I don't know, 5 minus 2 sine squared theta plus c. You with me?
Mm-hmm.
So very often what you don't realize is these c's don't have to be the same between these two. So a lot of times, do you see how this is related to a double angle formula? Just missing a minus 1? You with me? And do you see how you can take a 1 away from that because this is just the constant? So very often it's some kind of identity or some kind of simplification that you could do that would make one version look like the other. And I thought, maybe I'm wrong. No, I don't think that one said, there was a problem I think in Calc 1 where it said try to make the results look like each other. I don't think this problem said that.
No, it was,
Okay.
just, it was like multiple choice.
But it's a beautiful question because I don't give a shit what method you use, the answer's gotta be the same. And very often, the C has some shit in it that if you took it back out, you could see the identity that would make it look like the other two. That C is doing a lot of work. And it's kind of unfortunate we don't spend more time, but there's no real problem that showed up that really, besides this one to a certain degree. If you take differential equations someday, the C's are gonna rule you. There's gonna be a C1, a C2, a C3, a C4, a C5, a C6, and they're all gonna be different. You gotta be really careful with all of them. I'm not trying to make it sound horrible. I'm just letting you know there's a lot going on that C that we don't talk about yet. Is that better?
Yeah.
I'm not saying it's gonna be obvious all the time what connects.
It was just weird because then, like, as I was working through like the rest of the homework, I was like, okay, so if I do it like a different way, is like, am I getting the right answer, or is it just?
Oh
like,
yeah, I have to know, so that I'm not gonna just check it against what I got. I often get students giving an answer like, wait a minute, blah, 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 right? That's the same thing, okay, good, so I'm not, that's why I don't do Scantrons, for example, yeah. Yes? 2F? By the way, before anybody else need a practice test, is coming up here. Anybody else need a practice test? Okay. 2F, we talked about that one a little bit. Oh, what's up? You need one? Oh, okay. I thought I saw him. Oh, you're stretched. Okay. We talked about this one a little bit last class. Very first thing. What's the very first thing you should notice? Yes. They are talking about different angles. There's no way in hell that a U sub or something would ever work because they never are going to relate to each other. I've got to make the angles the same. I do not want to make these become 2x. I have three options for cosine 2x, yes? To make them talk about the angle x, not the angle 2x. Completely different angle. Do you guys understand that? Do you guys see that? No? Screw you, Jeff. I asked question, one answer. Do you guys see that? So now if I give you trig functions, one of the first things that should jump out at you is, are they all talking about the same angle? I think in the homework there's one we had an x and an x over 2. So you could go one of two ways to kind of rewrite it, and there's a better way to do it. You don't want to do the half angle formula if you don't have to, because that brings in a big square root. I don't want that. All right, so what the shit do I do? What are the options for cosine 2x? And if you don't know, the good news is you have time. You better know by Thursday. Because I'm the exact kind of asshole that's going to put this on the test. You have to know all the identities. Yes? So what are they? What could I put here instead? Yeah, so this is what I always started with. I always remembered, because that's really neat to me. It's like if you add them, you get 1. If you subtract them, you get cosine 2x. That's just so neat. But it's okay if you don't agree. What are the other two options? I can build from here. If I replace this with 1 minus cosine squared, bring the negative through, I get 2 cosine squared minus 1. That's another option. And then the other option is if I do the other way around, I get 1 minus 2 sine squared. Now, which one feels like it goes along with the other shit in here already?
The first one.
The first one. And in fact, this is what we talked about last time. You don't often look at it this way, but that is a difference of squares. That is factorable. Do you guys see that? So this is the kind of problem, if I put it on the test, I would grade heavier on what you tried to do. Because you sort of have to see how one is going to work with the other ones. And if you just don't have that click, it's a little evil. I don't know if you guys are with me at all. I have got to put some down there where you have to pick the right identity to use. I have to. But one thing I do for you is those ones I'll grade heavier on. Were the things you tried, did they make sense? Even if you don't get to the end. Does that make sense? Okay. Do you guys agree the first one seems to jive better? And especially now that you see it's a difference of squares. If I factor that, what do I get? So if we replace this with this. Good Lord, Jeff. All right, wait a minute. You got paper all over the damn place. Okay. And then I replace cosine 2x with cosine squared x minus sine squared x. And then if I factor this, I'll get a cosine x plus sine x, and now I have 8 of those, and then I'll get a cosine x minus sine x. Is that cool? Is that all right? If I factor this, I get cosine x plus sine x, cosine x minus sine x. That's how squares work. So the cosine x plus sine x, now I have 8 of them. And the cosine x minus sine x, now I have 1 of them. And then what kind of problem does this become? U sub. If I let u equal all this shit, if you ever have something in an integral that's stuck inside of a radical, on the bottom, in the denominator, and you don't know what to do, try u sub. Okay. So if you let this be u, du is effectively going to be this, and easy ass u sub. Is that okay?
Yes.
So what got that ball rolling was just stopping and going, the angles aren't the same. Oh, Jeff put a freaking trig sub. Okay, I got to make the angles the same. Then everything's going to work together. Just another thing to look for so you know what to do before you start trying to throw shit at it. You're like, this is a simplification step. You can rewrite cosine 2x. Is that okay? What else we got? Any of these problems, by the way, if it doesn't make sense what I'm saying, I can go further. If you don't know what to do from here, I can show you. Follow-up questions are always good. Yes?
Can you go over one on the practice test, please?
No. Oh, which one? One?
First one.
Yeah. Okay. So this one pretty much has the 2 things in it that confuse students the most. A repeated factor and a irreducible quadratic. So the whole thing depends on, can you write the form correctly? So this is where I'm going to have to give you more leeway also. Because if you write the A, B, C, D part wrong, I don't care what you do after that, you're never going to get the right answer. You agree? So then I'm going to grade you, you're going to lose points for that first thing, but then I'm going to give you points if you can do every step after that correctly. I'm going to not take more points away. You guys with me? Okay. Again, if it was Scantron, you wouldn't get that shit. With Scantron, my job would be so much easier. I would also suck more. So what's the form going to be?
A over x minus 1.
A B.
Over x minus 1 squared.
Yep.
Plus cx plus d.
Good, because they need a linear over this quadratic. Okay. Now, is everybody cool? Now, so what's he going to pick up? When I multiply by all this shit, he's going to pick up
One of those.
an x minus 1 and an x squared plus x plus 1.
Yeah.
He's going to pick up an x squared plus x plus 1. He's going to pick up an x minus 1 squared. And I can see that. If I multiply by all this shit, everything they already have is going to cancel. They're going to pick up the other shit. Make that step quick. Not so quick you make a simple mistake, but you guys kind of with me? I'm literally multiplying both sides by the denominator. So I can focus on the numerators and equate coefficients and whatever else I want to do. Yes,
How do we have 3x minus 1?
where are we at? Sorry?
3, so there's going to be 3x minus 1s.
Why?
Because there's 1 under A and then 2 under B.
Real quick, if I added those, what's the LCD?
2 x minus 1 squared.
There you go. Is that all right?
Yes.
Yeah. So it's kind of like, if I have something over 9, where could that have come from? That could have come from number over 9 plus number over 9, yes? I don't know if you get, like if I have 5 ninths, that could be 4 ninths plus 1 ninth. Well, it could have come from number over 3 plus number over 9, yes? That's what we're doing. We're just covering our ass. Do you see how number over 9 plus number over 9 is number over 9? So I've got that covered. But I need to cover myself with the fact that it could have been a number over 3. So that's exactly what's happening. It could be a number over one of these plus a number over both of them. Because then this guy would just pick up another x minus, and I can combine them. In the work, A might come out to be 0. But I got to cover my ass because it won't always come out to be 0. Okay. So I don't need 3 because I ain't got 3 of them anyway. This isn't 3 of them because it would end up being 2 of them when I made the like denominator. Okay. You guys with me? Yes.
I have a question. So for the end of this problem, when I started writing all the equations of like a plus c equals blah blah blah, I used like a matrix to solve it.
Oh, sure.
Okay, that'll
Yeah.
test. 'Cause I
Yes.
never, like,
Don't get me wrong. I kind of stayed away from matrices just because I love matrices. Don't get me wrong, but I know most students sort of don't. If you are actually a student that loves them, number 1, tears for you. Number 2, do it that way. I don't give a shit. Yeah. So you could totally never let x equal a number. You're like, whatever, Jeff. I don't want to do that shit. You just make a matrix. Kick ass. If you know how to put it in your calculator and do it that way, you just tell me that's what you did. That's fine too. Okay. Yes.
I have a question. It's on the homework, but like.
But real quick, I'm sorry. Did anyone need me to go further with this? Yes.
I just
No.
want to ask, for every problem like this, do we have to equate the coefficients for A and B and do all of that? Is that a step that's in every problem like this?
Not really. I mean, in this problem, it's going to have to be because one of these has something I can't let x equal to a nice number and make it go to 0. But you see, I can let x equal 1 and at least do a little bit that way. And then I'm going to have to start equating coefficients and making systems of equations. So that's why I said that let x equals a number is an option. And what I did as a student, and I still do to this day, is I do that as much as I can. And then whatever's still there, I make a system of equations for it. You guys kind of with me? By equating coefficients. So, let's do this. So after the first step here, I'm going to get, so if I multiply by the denominator, I'm going to get Jeff. Oh. It'd be funny if I write better without my glass. Can't write worse, huh? Let's see, x squared plus x plus 1, x minus 1, plus b, x squared plus x plus 1, plus cx plus d. I should have turned it the other way. I knew I should have. Okay. So what I would do is I would let x equal 1. And at least solve for b, right? You don't have to do that. You could go ahead and distribute, FOIL, distribute, blah, 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 and then all your x cubes have to add to be 1. Yes? All your coefficients of your, you guys kind of with me? It doesn't matter. So, which way do you want me to do this? Let me do this. Let me give myself some more room. Oh boy, this is going to be great. Oh God. Do you see how I already don't want to do this? Does anyone notice this is a cubes?
Mm-hmm.
So this will be a times x cubed minus 1.
Yeah.
Let me just truncate that a bit. And this is bx squared plus bx plus b. B of b. B of b? B of b. Okay. Plus, and then this is going to suck. Cx plus d, x squared minus 2x plus 1. I got to multiply that. So,
Yeah.
yes? So I get ax cubed minus a plus bx squared plus bx plus b plus cx cubed. Now here's what I try to do. Well, it doesn't matter, Jeff. Just do it straight. Minus 2c x squared plus cx plus dx squared. I'm just going to do this. Minus 2dx plus d. Woo! And then what does a plus c have to be? Because a plus c is a coefficient of x cubed, and the x cubed coefficient's got to be 1. And then you just keep going. Yes?
Yes.
B plus d minus 2c. That's all my x squared coefficients, yes?
Yes.
And then it has to be
Negative 13.
-13. And then b plus c minus 2d. That's all my x coefficients. They have to be 8. And then negative a plus b plus d has to be negative 5. Okay. Look at all that. You with me? Now, if you get to here, now I want you to notice something. Okay. All right. I want to point out a few things. Number one, the less you remember system of equations, the more you should try to do let x equals a number. Because that will at least decrease the size of your systems of equations. Can you guys see the second and the fourth equations up there? Does anyone see something that's intriguing to me? The second and fourth equations, for example. Don't they both have b plus d? If you change this one's sign and you add these together, won't b and d cancel?
Yeah.
Yes, ma'am.
So I know you see it like that, but that's where I got stuck, and that's when I started plugging in for x, because stuff would just cancel. So
Sure.
nothing was helpful.
Yeah, if I go back right now and I let x equal 1, I can figure out the value of b, and then I can put that number here, here, and here, and then my systems are better.
But when you see it, when you see two things in two equations, like the same thing that would cancel, is that how you just
That's
see it?
one thing I look for,
Okay.
is can I kill two letters at once? Do you agree with me that the main thing wrong with all these equations is how many unknowns there are?
Yes.
If only one of them had just one unknown, I would know what that letter is.
Yeah.
So if I can decrease the number of unknowns, yay. So here's what I mean. If I take this one, let me just write this one as is. And I take this one and multiply it by -1. So I have a minus b minus d equals 5. Yes?
Yes.
Now if I add these together, a, bam, bam, minus 2c equals, is that -13, Jeff?
Yeah.
If only you could write. And then I have this dude. And between these, if I change this guy's sign, I can kill the a's. So you're just trying to do stuff that will kill letters, because there's too many of them. Damn it. You guys that all with me? If anybody likes to do the let x equal 1, definitely do that shit, because then you'll know what b is, and all of these instantaneously become easier. Yes? Maybe? Screw you, Jeff. I'm just not going to do that problem. Nah, whatever. Are you guys? Okay. Yes?
What made you choose x minus 1 to multiply with the a minus b minus?
Oh, I'm sorry. Not x minus 1. There's no great way to show. I just multiplied by -1. I just multiplied this by -1. So the b's and the d's would cancel. Yeah. Okay.
Wait, so now you have, oh, okay, c equals.
So now if I add these together, I get -3c equals -9. I know c is 3. Yay! And then dominoes start to fall. If I know c, I know a. Yes? If I know A and C, I could try to figure out B and D. Yes? Okay. Maybe? Okay.
Yeah, I get that.
Still, you all love this shit. So, systems of equations are not going to go away. In fact, I keep talking about differential equations. There's a whole thing in differential equations about systems of equations. Systems of differential equations, even better. So you definitely want to keep the concept of systems of equations alive. That should be bread and butter. This should be something we just sink our teeth into and just knock out. Yes.
I have a question. So if there was no x squared on the left side and everything that had an x squared,
It would equal 0.
0?
Yeah.
Okay.
So if anything's missing, that means I have a 0 coefficient. So all the coefficients on this side would add up to be 0.
Okay,
Yeah.
thank you.
All right. Okay, I'm gonna move on. If you guys want to do another example as we can, if you want to move to a different problem, I think I shut down somebody who had a question because who had a question earlier that I shut down?
Oh,
Yes.
you just answered it.
Yay! Yes. That's the one I can't do. No, I don't. Let me see. 2G. Oh yeah. All right. So I'm just continuing on my quest to show you. Do I need a square root to show up in order for the right method to be trig sum?
No.
No, we've seen problems where I didn't have a square root, but I had the squared x in a constant, yes, and that jives with Pythagorean identity. So yes,
Yeah, I had tricks up for it. It was just the 3 halves exponent that was
okay. So let's do this. Let's just focus on this. What is your? So let's just focus on the bottom. Let me write the bottom. Okay. What is your sub gonna be? Okay, so 2 sine.
3.
Come back. Go away. Come back. No. Okay. So what's x squared?
4 sine squared theta.
So then this is 4 minus 4 sine squared theta. So the 3 halves. Are we with me so far? What does the 3 halves power mean?
Cubed.
Cube it and square root it. Doesn't matter which one we do first. I just have to do those 2 things. So I look at a fractional power as 2 things. If it's negative, then it's 3 things. Flip, power, root, blah, blah. Okay. I could take a 4 out, yes?
Yes.
Now, real quick, let's just do the number. What is 4 to the 3 halves? So what's the square root of 4?
2.
Cubed. There you go.
Yes.
And what's 1 minus sine squared?
Cosine squared.
What's the square root of cosine squared?
Cosine.
Square root of cosine squared is cosine cubed
Cosine cubed.
is cosine cubed.
Yeah.
So if I put a fractional power, if it's a 1/2 power, the power is 1. That's why I only think about the square root. 3 halves power, the power is 3. Square root it, cube it. So could I put a 5 halves power? I totally could. Sounds like something I would do. Wow. We'll find out. Is that okay? Of course, that's just one piece of the problem, but yes, the 3 halves power didn't really show up much, but of course I had to put it here just because I wanted to talk about it. You just gotta slow down and do it by itself, right? Yes.
Another general question about like 2A. So I did do it and I like got through it, but I used U sub for it.
Hell yeah.
But I did like but I know I did like the wrong substitution because I substituted sine instead of cosine. But can you explain why when you have like when it's like the odd even powers, why you want to do the even?
All right.
I got
All right.
close to the right answer, but not.
Everybody. Do you all agree? I think you all understand when I say this. This is one of the first things I said when we got in this. What is there an extra one of? Why do we say that? Because trig identities have square powers. So even numbers of things flow into trig identities. Odd numbers of things don't. So I would say there's an extra sign. Is everybody cool with that? Tangent and secant are a little bit worse because their derivatives are not directly clean. They're their own kind of things. But I have an extra sign. So whenever I see I have an extra of something, I pull it apart. So right now, I know what I want my du to be. I know what I want my du to be. Therefore, what must u be to make this be du? Cosine. Then I'm off by a negative and I can make that happen. Does that make sense?
Yeah.
So a lot of these are, you actually figure out first what your du is going to be. And that tells you what your u is going to be. That is one way to look at these. You could memorize bullshit about which one's odd and blah, 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 and they all just boil down to what I just said, basically. If they're both odd, then you can, whichever one. Yeah. Real quick, what if I had, is that okay for that?
Yeah.
What if I had this? Do I have extras of both? So I could choose either one. Does anyone see if one of them's a better choice?
Yeah, sine 44.
Which one's a better choice for you?
For you,
Sine.
sine.
Why?
Because it has more sine.
There's more of them. So if I wanted you to be cosine, let's just follow this. just to show you, I would pull one sign out, put it over here, and then if I let u equal cosine, this would suck. This would suck bad. Because I'd want to make it sine squared to the 23rd, and then I have 1 minus cosine squared to, I need you with me. When one power's higher, you want to let u equal to the one that has the higher power, because then that's going to be a direct u substitution. I'm not going to have to use a trig identity for that part. I don't want to. It's got a high frickin' power. Screw it. I'm going to pull a cosine out, let u equal sine. Are you guys, does that make sense? That is the one little thing that's something you sort of memorize or whatever, but there is a better choice if one power is higher than the other. They're both odd. Because technically I could choose either one. Yeah. Okay, maybe. Because this would be sine squared to the 23rd. 1 minus cosine squared to the 23rd. 1 minus u, no. Because we have a choice. We're the humans here. Okay. As far as that. Anything else? By the way, if somebody asks a question on like anything else, you can ask another question about the same thing. Yes? It's totally driven by whatever the shit you want to talk about. Is there a homework problem that's giving you a lot of trouble? Is there an idea you don't understand? Yes. Number 5 on the practice. Oh, that's the trap. Blah 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 blah.
Yeah.
Okay. So I'm going to give you these. So what's really funny about this problem is, how do I say this? I think I already told you this. I almost don't give a shit. I mean, what is the work you have to do for this problem? Yeah, it's calculated, but what's the actual work? I mean, delta x, you got to figure out that, right? How do you figure that out? Same way we do every time, Pinky. Okay. Right?
Yeah.
B minus A over n blah blah blah.
Yeah.
I'm going to give you the rules. You don't have to memorize them. And then it's just, can you get the function outputs for yourself and plug them in? Yes? So one way you could do this is to use the tables in the calculator, right? And I don't need a perfect answer, so you can just pull off as many decimal places as you see in the table. Another way is to actually put in your calculator, this would be a little insane, but you could do e to the 0 sine 0 plus e to the square root of 2/3 sine 2/3 plus, I left my 2 off. Yes, you can put that whole thing in your calculator. And then there's no rounding. You guys follow? So to me, the derivation was the most interesting thing about these, right? Why is Simpson's rule better is an interesting question. Yes? Could you guys answer that question if I asked that question? Why is Simpson's rule better than trapezoidal? Or
To the actual,
yeah, why is it closer to the actual?
because of the curve.
It's the
instead
only
of
one we've seen
line.
so far that's allowed to curve. Yes. And then it should make you go, wait a minute, aren't there other things? Yes. So, this is just get the outputs, throw them in, crank it out. You with me? I almost don't want to put this problem down because that's all it is. Just get the numbers, put them in, crank it out. But what's interesting is just comparing the answer and then getting the actual answer. I should have put that down here. No, I did. I did put that down there. I didn't do it, damn it. Compare your answers to what you find on your calculator. Yes? Hell yeah. Dear God. Don't waste time remembering those. You with me? Okay. No. I think I got that across to you that I don't really care that much about the error. Now listen, error is really interesting. But until you have like a specific field you're going into, the error almost is, it's a little amorphous. It's like how much you're off by, but I can see that just by letting the calculator do the interval. Then I can see exactly how much I'm off by. Error becomes really interesting when we're doing stuff in chapter 11. That'll tell us more about things. So we'll get there. So I will talk about error in general, but I don't care about it here too much. Is that okay? Is that okay? Kim, I think you asked a question. It's the hardest part of this is just can you get all of the outputs? The second hardest part is remembering to do the correct coefficients, but I am going to give it to you, but just as you plug it in. Yes? Just a real quick thing. I was doing this in Excel. Like if you use Excel, which you obviously can't get in here, you can make a table of the values. So I did 0, and then I said add 2/3 of that, and then I said keep doing that. And then I put the formula, and then I copied and pasted. But I forgot, I saw 0, and I thought, oh yeah, that doesn't matter. So I started my coefficients in the wrong place. So I was getting the wrong answer, and I was like, what the shit? And I realized, oh, I forgot 0. 0's got to be the one that's got a 1 coefficient. Everybody else here should have a 2 until the end. And my coefficients were a little off, and that's why I was getting the wrong answer. Right. I don't know if you guys follow that at all. Okay. Obviously, you're not going to be able to use Excel. Too bad. Okay. If anybody wants a quick little thing on how to use a table or something, let me know. Otherwise, I'm going to close the door on that one. Is that all right? Okay. Oh, one last thing I'll say. You don't have to graph the damn thing, but you should give yourself like a little idea of what your inputs are going to be, just to keep yourself straight as to what you're plugging in. Yes? Okay. Yeah.
Can you show us the setup for number 3?
Oh yeah. What was the idea with this? I mean, I want the area bounded by these curves. So what's the first thing I should do? And I really should be, okay. I inherently meant the first time they intersect. Because if you think about it, these are going to intersect an infinite number of times. So in one way you could say infinite, and you would be right. But I just mean the first iteration, right? Not the repeated. So I should have given a range of angles, but oh, too bad for me.
Well, technically you said in the first quadrant, so those are the
I know, but in the first quadrant, they are going to kind of like...
more than ones? 5?
Yeah, they should. Yeah, they should intersect a lot more often. I could plot it. So how do I find out? And we'll see it right now. How do I figure out where they meet? Because it's all about... Jeff. It's all about how they meet and what's gonna. So I need to know where they first meet and where they last meet. So I mean, that's crazy. And then we talked about the fact that I can't divide. I never want to divide by a function of x that could be 0, because then I'm losing answers.
Yeah.
So I have to subtract it, make it equal to 0, and factor. That age-old thing that we do.
Yeah.
So if I subtract it,
Yay.
factor it, either cosine x is 0, when does that happen? Yep. Or cosine of x minus 1 is 0, cosine x equals 1, when does that happen?
No, 1.
0.
At 0,
0
yes.
is, yeah.
Okay. So from 0 to pi over 2, that's where they intersect. You guys with me? Okay. Now, can somebody tell me the right answer? Because this is not the right answer. When is cosine x equals 0? Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. Right? So there's an infinite number of places where that's true. Yes? But I inherently just meant the first time that happened. And if I gave you this kind of problem, I'd be careful about giving you a range of angles.
Okay.
Yeah. Okay. So I'm going to integrate from what to what? 0 to pi over 2.
Yeah.
Now the question is, which one's on top?
Cosine
Cosine
squared.
So real quick, cosine
Oh.
x lives between what and what? Especially between 0 and pi over 2, lives between what and what? 0 and 1, yes?
0 and 1.
You with me?
Yeah.
When I square a number less than 1, between 0 and 1, the answer becomes
Smaller.
smaller.
Yes.
So then cosine x is going to be on top, because it's always going to be bigger, unless they're equal to each other. So this will be cosine x minus cosine squared x. And now it's just a question of, are you able to do that? I would break the integral up. You got a you got a power reduction, you have a normal cosine.
Is that true for every power? I said like anything less than 1 cube will get.
Of course,
smaller?
yeah.
Could you keep multiplying
0.8
by a
squared is
decimal?
0.64, 0.8 cubed is 0.4 something. It just keeps getting smaller, yeah. Yep. That's why if you plot in your calculator x to the 10th power, you get a very interesting picture. Looks more like a x squared looks like this, x to the 10th looks more like that. All right, that's all I'll say about it. Don't worry about it. Is that okay? Does everybody see how to move forward with this? That's a power reduction there, and that's just a normal cosine.
I think
Yeah.
the main thing that I asked my mom was like, okay, like I started working on it, and then I was like, wait, where's this like in between?
Oh, yeah.
Because I graphed it, and I was like, this just goes forever.
True. Yeah, okay, that was my fault. I should have said something about the angles.
Well, you said the first quadrant, so isn't x restricted to 0, 5, or 2?
All right, we gotta be really careful. You're thinking about the unit circle, which is not an XY graph. It's actually more of a, you can even think of it as a R theta graph to some degree. So that's not, when I say first quadrant, I meant literally the
Positive.
XY first quadrant, yeah. Although, now that you say that, I could have pretended like that's what I meant, but I actually didn't. Yeah.
I mean, it still works.
It still works, yes. It would actually, that would clear it up, but to be honest, I don't think I meant that.
First
Um,
quadrant of units.
Because if I go the graph back this way, out of the first quadrant, it interacts more often over there. Okay, but you're right. I could have pretended like I meant that, but I didn't. Okay. This is an idea from Calc 1, right? Chapter 6, section 6.5, I think, where you just found the area bounded by the curve. So you see where they meet and see who's on top. And you put the one on top first. But, of course, now we know how to integrate more shit. So all the old stuff we did still works, and now we're able to do more of it. Yeah.
And we're only getting area questions, right? No volume.
No, I'm not going to do volume questions. I might make a bonus. I can do whatever I want to in the bonus. By the way, I don't know if I've said this, but if you add me for Calc 1, I still do bonus. I do like 3 bonus questions, so you could get up to 106 on the test. So there'll be 3 bonus. You don't have to do any of them at all if you don't want to. Yeah. Yes?
Is the test going to be the whole class period?
Yes. I'm going to design it to take less time than that, but you get the whole class period. Yeah. Yes.
Does it take you the same time to correct it as the quizzes? Like next class?
No, real quick. Everything except homework corrections. When are they due? Day of the next test. So when a test 1 correction is going to be due? The day of test 2.
No.
See? Everything is due the day of the next test except homework corrections. They're due day of the final. Yeah. If you're in WebAssign, your homework corrections are the fact that I gave you 3 shots. So you get 1 more shot than the textbook people do. So I don't want to hear nothing. And you're going to give me no infinite tries. Yes.
I meant, when would you correct them? Like,
When will I do what?
correct them as in when will we get
I
our
don't know.
score? Yeah.
Shit. I gotta be very honest with you. Homework corrections are the bottom of my priority list.
No, but I mean the test.
Oh, the
Like, this
test. I'll give
Thursday,
it back
will
to you
we
the
get
next
it
time I see you.
Tuesday? Is that
Yeah.
next class? Okay.
Yeah. Yeah. Even the classes where I meet the next day, I somehow grade the test by the next day. I always hated as a student. I couldn't really focus when I'm like, I got this test out there. And I'm sure you've had classes where it took like a couple weeks for a teacher to grade a test. And you're trying to learn new shit, but in the back of your head, you're like, how am I even doing it? All right, how am I even doing it? So I try to give it back to you the next time I see you. No, I do. I always do. So, yes.
Is chapter 7 homework is due the day of the test?
Yes, there you go. Chapter 7 homework is due this Thursday. That's true.
Quiz corrections are also due.
Quiz corrections due this Thursday. So let me say it earlier. When is everything except homework corrections due? Day of the next
Day
test.
of test.
What else was I going to say? Oh, homework. if you are like really far behind, stop trying to do every homework run. Do every other one. Do not come Thursday with entire sections that you did nothing in. That makes no sense. Homework, dear God, I wish it would work a different way, but it just doesn't. We're all human. I have to make it worth something. I wish you could make it worth nothing. You do as much as you need to understand it, and you ask questions, but unfortunately that just don't happen. And I don't blame us. I wouldn't do it either. I'm human. I got stuff with deadlines, and you're telling me no deadline? Well, screw you. I'm going to do this shit with deadline. So I have to put it on my... And then students will either not do any of it, or you'll go insane trying to do every problem. There's got to be a midpoint. You need practice. The whole thing is practice. So I have to give you a wide variety of stuff. I have to. You make this shit your own. This is your education. I'm just one person along the way. You make it your own. You do as much as you can. Out of every section, make sure you've touched every section. Don't just do the first 3 problems. Do some from later. Come in with practice from everything. And then just give me whatever the hell you got. And I'll be like, finish this. Calm down. Yes.
So if we have 1 or 2 problems that we started, but we kind of are crunched for time, we turn in something, or if you see that we started, we just didn't finish it, do we get a deducted score? Is it just...
If you do that once or twice, I might say okay, even though you have a couple you didn't finish. If you do that too much, then I'll say finish, or correct or whatever, yeah.
So it's just kind of like any other problem where you have the correct on there and you just go back and fix it? It's
Yep.
not necessarily...
Sure.
I mean, if you got 2 problems that you didn't finish, or 2 problems you didn't even do any of, but everything else looks great, I might say okay,
Does it help?
or I might say finish, it depends, yeah.
Yes.
Do you do the same for website if you look at 2 problems like the
So WebAssign, again, I think I told you guys earlier, WebAssign, you don't have to have 100% showing to have full credit for homework. Textbook people, they don't have to get every problem right to get full credit. Same thing for WebAssign. If you have a less than 100%, that just means you made a few mistakes. A few mistakes for me could mean full credit. You guys with me? Another reason why I hate online, I just hate online homework, but some people like it, so what the shit? I'll let you do it. I finally replied to a few things in WebAssign. I hadn't logged in a while. Some of you guys wrote to me just to say, I got this wrong. I'm like, yeah, you did. But some of you guys wrote to me to say, WebAssign said this was wrong, it really wasn't. And I'm like, yeah, you're right, blah, blah, blah. Right? So I think I got back to everybody, I can't remember. Okay. If I'm not getting back to you, just send me a normal email. Because I don't always go into WebAssign. Okay? All right. What have we not discussed yet? How are these? Oh, go ahead. I'm sorry. What you got?
I was really just gonna say this.
Oh, these? Oh, neat. So what's up with those? 4A and 4B? Do they have the same kind of problem?
No.
Mm-mm. What's the problem with 4A? By the way, I think the book calls them type 1, type... I don't give a shit. Just what's the problem with 4A?
When we have 3.
3 sucks.
Yes.
So now you know how to rewrite it.
Yes.
And then it's just a normal integration problem where you plug in T in instead of 3. Yes? And then the last thing is, it's a limit problem.
Yeah.
Which I know might bring back some trauma for some of us from Calc 1. I'm very sorry. Somebody out there was like,
I think
Jess, I'm sorry. Now, do you want to, did 4A specifically, I made it a certain kind of problem where I'm hoping some of you guys realize you did not have to do trig sub. Yes?
Yeah.
Did anybody try to do 4A with trig sub? That would be, I'm sorry, that would be horrendous. If the top was squared, I would have to do trig sub. If the top is a first power or a third power, I could use U sub.
Yeah.
Just to remind you guys, how does that work? What would I let U equal in number 4A?
I can't see that.
Too bad. Oh,
At the bottom, inside the
yeah.
radical,
So what's du?
2x dx.
So I just need one x, right? I've already got my 2. I just need 1. But that leaves 2 x's unclaimed, but I can solve this for x squared.
Yeah.
Right?
Yes.
So one of these x's goes with dx to make, and goes with 2 to make du, yes? And then that leaves 2 x's behind that I can replace with this shit.
Yeah.
The whole idea of u sub is everything that was x needs to become u. U related, right? As long as you could do that, u sub could work. You could actually do the first step at least, but the integral might be gross afterwards, but you really hope it isn't. Is that all right?
So if you wrote that for the top, then the top would be rewritten as like
Yeah, so let's see.
as du, but then it'd be u plus 9 du.
So it would be, just to kind of break this up a bit, I'm not gonna worry about the limit yet, but let's just look at this. So it'd be 2x squared. I could have wrote that better, but too bad for everybody. So this is du, and this is, yeah, so I can replace everything on the top with u shit.
Okay.
And then the bottom is what I'm directly replacing with u inside there, yeah? So then this would become, don't worry about those, I don't care. U plus 9 du over u to the 1/2.
Yeah.
Which now the bottom is one term, so you can break this up. Yes? Okay, maybe. Now, you should have limit as t goes to 3 with a t here, yes? I don't want to do too many things at once to worry about. With an improper integral, once you do the limit, the next several steps are normal, just like you would do with any integral. It's just at the end you have to bring the limit into play. So you should get a finite answer for part A, or if I remember correctly, and part B is neat.
Yeah.
Is that okay for part A? Part A. What goes on part B? So here, this is a very direct kind of like this here, yes? Jeff. Oh my god. What's the integral of sine?
Negative cosine.
Yeah. So you get the limit, t goes to negative infinity, negative cosine of -1 minus negative cosine of t. And what happens if you try to let t go to negative infinity? This guy's cool, he's just a number, you don't care. But what happens if I try to let t go to negative infinity for cosine? Yes, what kind of divergence is it? Because does cosine go to infinity? No. So it's not that kind of divergence, but for a limit to exist, it has to get closer, it has to get infinitesimally closer to something. And cosine never does. It's just always far away from everything. Right? So it just never agrees on something. So anyone remember what we call that? I mean, what does sine and cosine do? They oscillate. So this is oscillatory divergence. Yeah, which is just a neat word to say. Oscillatory. Is that alright? Yes?
Do you want us to specify that on the?
No, you could just go, I don't know what you would say. What would you say here? I don't know. You can go, it never goes anywhere. So it just diverges. I need something as to tell me what part of this has an issue. So at least put a little arrow. This part has the issue, Jeff. It diverges. You can say really quickly, never goes to something or something. You don't have to say oscillatory divergence. Yeah. If you did, that'd be great. But you don't have to.
Yeah, but you need the product.
Oh, yeah, for why it's not. So it's on.
So you could just put divergence.
Yeah. So I have to be careful because I think a lot of the examples we did, the improper intervals actually converged. But I just want to remind you guys, they don't have to converge. That's why they're improper. They might go to infinity. Yes?
Did you happen to have one
Yeah,
of
if
my
it goes
quizzes?
to
Do what? Sorry?
One of my quizzes,
Oh, what's your name again?
David Walters.
David, I got a whole bunch of shit for you. Get up here. Here, let me try this again with people. Emmett is here. Michael Cervantes is, of course, way over there. Chris, it's right there. always say your name wrong. I know I do. Macy. Skylar? Sumrine? Miranda?
Can't do something like.
Luis? And you?
3 times 3 is 6. Yeah,
Okay.
3 times 3 is 6.
All right.
9.
Where to next, guys? Yes.
Do the last problem from 7.4.
The last problem from 7, which one?
I can't remember from 7.4.
4.
I can't remember which one it is, but it's like the last like x to the 4th plus 17, and then you do the
Let's see.
like 70 or 60.
Oh, let's see. I don't.
Oh, it's 72.
72. Oh, there we go. Okay.
Yeah, I don't know how I said that right.
Oh yeah. Okay. All right. So. So we have this, and what they're asking me to do is something that happens a lot in mathematics, is to add and subtract the same thing. Got it. Where'd it go? There it is. All right. So, let's see how it says. What could you try to add and subtract here?
I think I did plus 5 minus 4. So it would be
Oh, I see.
minus 4. I don't know if that's.
Okay, interesting. So, yeah, so you're thinking about the constant. So if you subtract 5 and add 5, but see how that doesn't, I mean, it would make this a difference of squares, but then the overall thing wouldn't really, this, yeah, the square number here would be better.
Plus 2x squared minus 2x squared.
Alright, so now we have an example of, instead of focusing on the constant, do it again, you said,
Plus 2x squared minus 2x.
so that you could try grouping. Now, the problem, is that my tongue? If I switch these around, let's see what happens. Can you factor this? Yeah, of course you can. What do you get?
X squared plus 1.
And is this a difference of squares? Sort of. If only had a better number here, right? That's another approach to take. Yes? So you can either, you can either try to do this, but maybe pick a better number, but then that might not get you where you want to be. Or you can try, where'd it go? There it is. To add something like in the middle to go somewhere. Yes? So like this, let me see. This would be x squared plus 1. I don't think this is what they mean though, because that looks really gross. Times x squared plus 1 plus rad 2x. That's gross. Yeah, I don't want to do that. So let me think, what do they mean here? Yeah, you'd have to play with this more. I mean, if this was a problem, yeah, because I don't remember what the right solution was, so I would just keep playing around. So I tried 2x squared, and it felt like it was sort of going somewhere. But then it ended up here. And this is kind of gross. I don't like that. Let me think. All right, I don't want to spend all day on this, but we could try just doing minus x squared plus x squared, but that probably won't go anywhere. No. Yeah, off the top of my head, I'm not sure, to be honest.
I'm trying plus or minus 2x on the numerator, because I can see that x fourth could be x squared squared.
So they specifically want us to work with this.
They specifically want you to look at that.
Yep, it says factor that as a difference of squares. Yeah, so let me see.
Can we do an x squared and a number? Would that help? No.
Potentially. This doesn't make,
As a difference in squares.
let me think. I almost feel like that last thing we did was close to what they want. Yeah, off the top of my head, I'm not sure. I have to play around with this. Let me see. That's interesting. So like, all right, like that. No. Obviously, that won't work. I'm trying to think. The signs won't quite do what I want them to.
Are you sure it's x fourth plus 1?
Yes. Mm-hmm.
Crazy.
Yeah. Yeah, I can't remember this solution, but I'd have to just play around with this. So like, this feels close. Oops. And then if we switch things around, it kind of gets somewhere. I don't think that's what they mean. Let me think. I don't know, I have to think about it. I'm not gonna like hijack the rest of the class thinking about this. So, is this an easy problem? No. Because I don't normally consider doing things like this. It's not coming to me directly, so I'd have to sit down and play with it. But you guys see what I'm trying to play with? I mean, that's the point of this kind of problem is, can you play with this? I'm trying to imagine what they. Anyway, I don't want to waste too much time.
Like factor by grouping?
Yeah, I thought maybe it was. To me, it felt like they would want it to eventually become a squares, and then we could do it. So this makes it into a squares, but this definitely doesn't feel like it would do anything good for us.
Yeah, and the way that I was trying to do it would have been horrible.
Well, if we look at just doing a number, if we, yeah.
You get two factors and then you get plus like a constant, and then that's like a.
Because I mean, you would want this to be like this, because then you could factor it twice in a way. Oh, wait. Are we in 7-4? Oh. That opens the door. Okay. I thought we were before that. This is gross. But this is factored. So then you could actually do partial fractions, believe it or not. Even if you have a coefficient that's not whole. But there must be a better option to pick. Yes?
I think the textbook wanted you to do the root 2 factorization, because I was doing it yesterday, and the professor who was helping me in the lab told you that it had a root 3.
Yeah, maybe it is this. I thought we were before we were allowed to do partial fractions. But that actually would make more sense. Plus it's number 70 something, so it being kind of gross like this, oh well. So real quick, okay, let me make this a little cleaner. Oh my god, I was like, I couldn't figure out how that was gonna help, but then we're allowed to use partial fractions, so it's great. So we start with this. We add and subtract, but I'm gonna do it in a special way. So then everything's the same as it was. And then this is, oops, I left out that. There we go. X squared plus 1 squared. Oh yeah, I did have that. And then this is a difference of squares. Right? One thing squared minus another thing squared. So this is x squared plus 1 minus rad 2x, x squared plus 1 plus rad 2x. And now it's already factored for you. And then you can do partial fractions. One coefficient is radical 2. Oh well. Too bad. Yeah, it doesn't.
Such a ridiculous problem.
Say again?
Such a ridiculous problem.
Oh well, too bad.
It's kind of funny though.
I mean, this is a really good example of reminding you that there are little things that you can do in general, but aren't like something you would do all the time.
Mm-hmm.
So this idea of adding, subtracting something, it happens more often than you might think, but not often enough that it's something I automatically think about doing. You guys kind of with me? It's sort of like remembering that one factorization of 80 is 16 times 5. I don't use that factorization often enough to just kind of like know what I do, but you know what I mean? We don't do that. So I like this problem. I do. I would. Doesn't mean I'm going to give it to you, don't freak out. Listen, if that was not a rad 2, if that was a 7, that's just a normal partial fractions, right? Okay. Rad 2 is just a number, so it's still just normal partial fractions. Okay, maybe. How do I say this to you guys? Was this obvious? No, that's not the point. It's not the point. This is the kind of problem where if you try a few things and you're like, listen, I really don't know. I'm going to look at what you tried, see if there's logical sense to it, and that's what I'm looking for. This is not something that we say, here's example 7, this. No, this is some weird little side note. I know somebody, at least one person here, there's so many cool YouTube channels that talk about these really eccentric ways to do these freaky intervals. And every time I watch one of them, I'm like, I never thought about doing that. And I teach this shit. Do you understand what I'm saying? So I don't want this to make you feel like, what's the point? But we constantly are learning new things to try. That's the whole point. Integration is weird. Integration is undoing something that's already weird. Quotient rule. It's weird. What if I have to undo it? Holy shit. Way weird. So, what I'm trying to say is don't leave things blank. Don't erase everything you do. If you don't get to the answer, okay, you didn't put the icing on the cake. I'm going to grade the freaking cake. Yes? Okay. So yeah, this one I didn't like because I was like, where the hell did that go? And then, but if you can use partial fractions, that'll work. So really quickly, if I have this, let me write it a little bit better. Jeff. Barf. How would I, oops, I made the wrong things. Okay. This would be like ax plus b over this plus cx plus d over this, yes? Okay, so, I mean, you can just brute force this sucker. Do we wish it wasn't rad 2? Down there. Yeah, but it is. I don't care. We're just going to deal with it. Okay. And kind of hidden in here is sort of a potential fourth power factoring rule. Kind of feels like two big dudes, like cubes are little dude, big dude. This has big dude, which is neat. I didn't even think about that, but there is something like, yeah, go ahead.
Could you use trig substitution and make tangent equals x squared?
Oh, from the beginning on this problem? You mean like here? Let x squared equals tangent? Totally, yeah. I mean, that's something you could try, but the problems gave us a very specific thing we had to do. Now, if you're the kind of student who tries to do what it says and then says, let me just try this trig thing, even though the problem didn't say to, cheers for you. That kicks so much ass. Try it, why not? It didn't say to, but that's not your point. You're not gonna be constrained by what a textbook tells you to try. You should be trying shit, why not? Maybe. Do you have to? No. But that's neat. Now watch this real quick. How do I do the derivative? What's the derivative of x squared?
2x.
2x dx. So that could be a problem, yes? Equals secant squared theta d theta. That I don't see. But in general, if there was an x up here, that could work, yes? Okay. Or you can make x equal to square root of tangent, but I don't want to take that guy's derivative. I won't do that shit. Okay. So no, you don't have to do tricks into that. It was just a neat suggestion. Okay. I agree. So let's see. Anything else? Let's see. I don't even know where I put my practice test at. Oh, let me give you the answer key before I forget. Yeah. So very quickly, some of you guys have had me before, and you've heard this, but some of you guys have never seen me before this semester. If you did not try the practice test, don't even look at this. What you're going to do is this. Yeah. I would have done that. Yeah. And you're going to build this false confidence, not good. Do you understand? Now, once I give this to you, you can do whatever the shit you want, so you can look at it all day long, but try not to. If you haven't tried the practice test, don't even look at this. It's going to take me a moment because there's 2 pages there. Anytime.
Oh, you want me to handle it?
I was checking my answer for
I don't know what my question is.
It is my writing, so. I remember one time some student said, "Did you write all of these?" Sure. I wasn't planning on it, but if you remind me, I could. Yeah.
Why did you put that here?
Because that's all the problem wanted.
Oh!
Yeah.
Oh, that's right. I think it was just to set up the tricks,
Just trying to tell you did too much.
When I saw that, I did the whole thing, and I was like, oh shit, so I put wrong answer and then right answer.
I had no idea, yeah.
So I'm really sorry, I didn't even grade it to see if it was right, because I had enough stuff to do already, but just to let you know, that's all I want.
No.
You see the,
Yeah.
make sure.
Is he sick or was he?
No, he's not gonna be there.
Nope, I'm not finishing this.
That means.
I'm just gonna go straight to the sizzle. Yeah.
I'm gonna go grab food and then come back. But start workout.
Alright.
Direct substitution.
Alright. Let me know if I made some mistakes.
I think honestly.
Yeah, I make mistakes, so which,
QA
I was trying to do
it's
Oh.
definitely.
4 plus 1. I tried 1 plus 2x.
Oh, yeah, you're right. You have plus C.
I can try to do a trick.
Oh, I forgot about this, okay.
Yeah.
It wasn't going.
So on 2A, everybody, I forgot my limits to evaluate. So right here, it should be between 0 and pi over 2. And what's interesting about cosine of course is when I try to plug a pi over 2, they both go to 0.
Yeah.
When I plug a 0 in, so it'll be minus negative, so it'll be, and they both would go to 1, yes?
Yeah.
So it'll be 1/3 minus 1/5,
Yes.
which is 2/15. So it should be 2/15 on 2A.
Yeah.
Is that cool?
215?
2/15.
Okay.
As Sue said, that's right. I feel pretty good.
Oh,
Um,
sorry then.
I'm averaging about a 97 on my answer keys. I feel pretty good. So.
Nice and during the time you get it right 100% of the time.
What's up?
97% of the time, you get it right 100% of the time.
Yes, 97% of the time, 10% of the time, Jeff works every time. This one we just did. I think I did all of them right. Oh yeah. This is the mistake I told you about. I had the wrong number in there at first because it should be 13 point blah 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 blah. And one thing I didn't do, you guys all know how to check the actual integral on the calculator, right? Where you do the second calc, number 7, the integration.
What?
How to make the calculator do integration for you. Do you know how to do that? Okay, let me show you. So the function was e to the square root of x sine x, is that right? E to the square root of x sine x, yeah? Is that it? I don't have my,
Yes.
yes, okay. E to the square root of x sine x zoom 6. And then I want to go from 0 to 4, is that right?
Yep.
Look at that, isn't that neat? Okay, so square root, so I want to second calc, number 7, integrate from 0 to 4, and watch this, this kicks so much ass. If you've never seen this before, you should go kick your Calc 1 teacher, but look at that shit. It shades it in, wonderfully visual, and you get 4.67 roughly. So this Simpsons is almost the same, and this is, you know, decent for 6 Lego blocks of shit, so that's not too far off, but that's really good because we allowed it to curve, so of course it's gonna be better. How's everybody? Okay. That's good to know. If anybody didn't know how to do this, you're so welcome, because now
Thank you.
you can check easy integration. If you have definite integrals, obviously this can't do indefinite, but if you have definite integrals, you can check it on your calculator. Nice. Huh? Oh yeah, yeah. There is a direct way to do it, but I like the visual though. Of course I do, but math you could do the direct. Number 9, function integrate. That's just so. What's the word? Sterile. I don't like the visual. I like the visual of shading the graph in.
Oh, great.
It's okay.
So I want to say I love it. I appreciate the students who get frustrated at a problem. But we have to remind ourselves at that point, how many have you done successfully when you get to that problem? Yes? I think sometimes you forget about that. You only highlight your own, like what you perceive as failures, and you forget about all the successes you had before that. So there will be problems that trip us up. There just will be. I don't care how much math you know. There will be problems that will trip you up. I love that little saying. I'm pretty sure I have it on our homework sheet about doing math right is not about if you get the answer correct. It's what you do if you don't know what to do. It's what you do in those situations, right? And you just try what you know. You just try what you know. So on the test, don't spend too much time on a problem. If it's really kind of driving you crazy, just show what you're trying and then move on. Come back to it if you have time. Right? Don't let it dominate and you don't even finish your problems. I'm going to do my best not to give you something that's going to be like excessively trippy, but there will be a couple of trippy ones. They just have to. How many of you guys have like other tests this week? Anybody? I know there's some chemistry tests happening. Yeah. All right. We try to get together before the semester and plan tests for everybody to screw students over. So we'll try to do better next semester. Have more hands up. Anything else you guys want to talk about? Do we have other things on the practice tests that look not what we expected? Or on the answer key? Oscillatory. Oscillatory. So here I did that combination of that Now, what I do is I try to think ahead without actually multiplying the shit out, because I hate multiplying the shit out. So that's where I came up with these. It's alright. Let me think. Anything else that's trippy? There's that one problem we did together. That's the way I did it too. The one with the cube root of x on top and bottom. It is so cool that I've done so much math, and it's really easy for me to go find something I had never thought of. It's crazy. Students, I feel like you might see that as despair, because you're like, I'm never gonna learn everything. But I always think that's so beautiful. I'm like, I always want every day to go, I never thought about doing that, holy shit. I want that. I don't wanna ever get to the point where I'm like, yeah, it's the same shit, it's the same shit. So I don't know what I'm trying to say.
Wait, what happened here? 25 I have a question here.
Yes.
Maybe I'm just about.
No, it's probably me.
So right here, 18, so
Okay, so the derivative
plug into
of
5,
secant
right?
is secant
Yeah.
tangent, right?
That should be 4, 36.
Derivative of secant squared is
25 minus 9, 16. Oh,
tangent?
yeah, that's neat.
Remember
Okay.
secant,
That's when the
remember secant,
What was I thinking about?
If you
Oh, I
use
square rooted
two
16 twice, apparently.
tangent left.
Yeah, so it should be
Secant,
plus,
tangent, another
72.
72, yeah.
Wait, that's so far. That's so far.
So right here,
That's one of the things
Where'd it
I
go?
always get wrong. When you do an integral of secant squared.
over
I
here.
get them mixed
And
up.
I started
Number-
random
I don't even know,
tricks
this
to
is
get rid
4?
of it.
Yeah,
When we
I think.
Tangent.
Right there.
I think right here, when I plugged a 5 in, I got 25 minus 9 is 16, square rooted it got 4, and then for some reason I square rooted again, because I doubled 18. I should have multiplied 18 by 4, so I should be 72 there. Should be. And if I would have taken some time, I could have put this in the calculator, double check, blah, blah, blah. I'm really curious if it could handle improper shit.
It does. Surprisingly.
Nice. Very nice. So yeah, that should be a 72 there. So that's something I could have done if you do 72 plus this in your calculator and then just double check it against what second calc number 7 gives you. Like that's a great thing. So that should be 72. Yeah. I'm not good with numbers.
I did 2 plus 12 equals 20 last semester. I can't talk.
I mean, anybody should. I've had teachers that said, I'm the math teacher here, I don't make mistakes. I'm like, oh God, aren't you dumb? I don't want to ever set that bar for myself. Are you kidding me? Is everybody with me?
I should have just said diapers.
Okay. Anything else you want to go over with an example problem on? If you're ready, you can leave. Some of you guys are staring at me. You can always leave early if you want to on a review day. No problem. If you have questions, let me know. And I think everybody's like, I don't want to go anywhere in case somebody asks a good question. Okay. So if you're really behind on homework, just like I said, I'm not saying I'm going to be cool if the homework's not finished. You're going to say, that's nice you're not cool, Jeff. I'm doing what I can. That's you making your education your own. Just get ready for the test. Do as much practice as you can of every section. If you don't do every problem, who cares? Do as much as you can. Okay.